Okay, in this video we'll start to talk about problem type number 8, which is very similar to our distance equals rate times time problems with the chart. So the goal of these problems is to show that we can extend that strategy, that technique, to deal with more problems and other types of problems that on the surface appear to be different but underneath are really the same. Alright, so here we have a certain computer database. To use it charges $30 an hour during the day, $10.50 an hour at night. So you see there are two parts to it. There's a daytime part, there's a nighttime part. The research company paid $450 for 28 hours of use. Find the number of hours charged at the daytime rate and at the nighttime rate. Now we have a very similar structure, but instead of distance here, we have our cost, or the charge, and that's equal to the rate, which is the fee per hour, times time. So it's almost exactly like distance equals rate times time. It's the cost equals rate times time. And we have our daytime part and our nighttime part. Well, we know they charge $30 per hour during the day, and they charge $10.50 an hour at night. Now we don't know the time, either of the times, but we do know the total time was 28. Again, when we know the total time, we make 1, and it doesn't matter which one we use, as x. We just need to make sure we record it carefully so we know when we're done, we'll know what we actually have solved for. And the other one is going to be whatever's left over when we subtract that amount from x. So we have 30x for the first, 10.5 times 28 minus x for the second, and now we're ready to set up and to solve. So 30x. Now, great. I'll stop right there. Remember that here we're not told that the daytime cost and the nighttime cost are the same. What we are told, though, is that the company paid $450 total dollars. So what that means is we have to add the daytime cost plus the nighttime cost in order to get the total cost. So here, instead of setting them equal to each other, we're going to add the two together. And so when we do, we'll have to distribute on this side, and we'll get 30x plus, we want 10.5 times 28, times 28 is going to equal 294. So 294 minus 10.5x is equal to 450. What we need to do now is to combine like terms on the same side of the equation. So we have a 30x and a negative 10.5x. When I add them or subtract them, that will give me 30 minus 10.5, which will give me 19.5. 19.5x plus 294 equals 450. Now some people might want to subtract the 294 first. I'll do it later, but there's nothing wrong with doing it that way. So we end up with, after we subtract 294 on both sides, we have 19.5x is equal to, and that's going to be 450 minus 294 is equal to 156. That point, just dividing 19.5 on both sides. 156 divided by 19.5 is going to equal 8. So x is 8 hours here, looking at our chart. 8 hours, and 28 minus x would be 20 hours in the evening. 8 hours during the day and 20 hours at night. If we really wanted to check this, which we should, we can multiply 30 times 8, and that would give us $240 for daytime usage, and 10.5 times 20 would give us 10.5 times 20 would give us 210 for the evening, and 240 plus 210 equals 450, and so we've checked our results there. All right, we'll go on to the next problem. In this problem, a woman invests an amount of money in 2 accounts for 1 year. Again, so this tells us it's not just a simple plug-in interest equals principal times rate times time, which is what we have here. Interest equals principal times rate times time, but we have 2 things going on. So we are going to set up a chart, only this time we're going to have 4 columns because we have interest equals principal, that's not an R, times rate times time. Whether we use capital or small letters doesn't really matter, and we have 2 accounts, the first account and the second account. Now in these 2 accounts, we know one of them, the first one, is going to get 8% interest. Remember to write that in as a decimal, like 8 cents. The second one is going to get 6% interest. Now we know that the total amount invested, principal is the total amount, is the amount invested, is $1,250. So what do we know here? We also know that this is only 1 year at the end of the year, so there's only 1 year here. So now, since we know the total principal, we don't know the individual amounts, we put an X for one of them. And then we're simply going to subtract that from the total, giving us $1,250 minus X. We're going to put a certain amount in the first account, then whatever's left over we're going to put in the second. How are we going to find what's left over? We simply subtract it from the total. Subtract the first amount from the total. Alright, so we're ready to go with this. We have 0.08X and we have 0.06 times 1250 minus X. Squeezing that in there, and we can set up our equations. Slow down. We don't know that the 2 interest amounts are the same, but we do know that together they add up to $86 in interest earned at the end of the year. So we're going to add the 2 interest amounts. We get 0.08X plus 0.06 times 1250 minus X is going to equal 86. Alright, so we're going to need to distribute. On the left we have 0.06 times 1250, and 0.06 times 1250 is $75. So we have $75. Now you have to be really careful here. You're distributing 0.06 to negative X. So we don't want a positive here. We want a negative 0.06X. And so that should do it for the left side. Right side is simply 86. Now we're going to combine our 2 X terms on the left. 0.08 minus 0.06 is 0.02X plus 75 equals 86. Subtracting the 75 from both sides, and we get 0.02X is equal to 11, and 11 divided by 0.02 is $550. So dividing by 0.02, 0.02, X equals $550. And looking at our chart, that's the amount of principal invested in the 8% account. To find the amount in the 10%, in the 6%, sorry, we use the formula 1250 minus X, which is 1250 minus 550. If we want to use our calculator, 1250 minus 550 is $700. So $700, that's the amount invested at 6%. We'll go on to the last problem in this set. Okay, in this problem, a woman invested her savings of $8,000 into two accounts. So we set up our structure here, and it's a total of $8,000 invested. Remember that the amount you invest is your principal. One of the amounts is 9%. We write that as a decimal. One of the amounts is 7%. Both of these are for 1 year. And again, when we know the total but we don't know the individual amounts, we're going to place an X in one, and then whatever's left over from the 8,000 we'll put into the second account. And so we have 0.09x is our interest for the first, and 0.07 times 8,000 minus x is our interest in the second account. What we do know about the interest earned is that together they made $630 in interest, and so we're going to set up our equation as such. 0.09x plus, we have to add the two interest amounts together. 8,000 minus x is equal to 630. So we need to distribute on the right, and we get on the left, sorry, 0.09x plus 0.07 times 8,000 equals 560. Then remember, this is 0.07 times negative x, so it's minus 0.07 x, and that's it for that, is equal to 630. We have two terms to combine, the 0.09x and the minus 0.07x. That's going to give us 0.02x plus 560 equals 630. Subtracting 560 from both sides, and we get 630 minus 560 is 70, and 0.02x, dividing both sides by 0.02, 70 divided by 0.02 is 3,500. So x equals 3,500. So we know that she invested $3,500 at 9% because that's where our x is in the principal on the first account, or the 9% account. And if we wanted to calculate, we could do 0.09 times 3,500, and that would give us 3,500 times 0.09 would give us $315. Now, if we know that she put $3,500 into the first account, and she had a total of $8,000 invested in both accounts, then it must be 8,000 minus 3,500. So 8,000 minus 3,500, or 4,500 invested in the second account. And if we wanted to test to check that we were good there, we would multiply 0.07 times 4,500, and there we get 315 also. Okay, that's fine. She just happened to make the same amount in both accounts, but together we get 630, and that checks out. Alright, so that's going to do it for this last type of problem, which is type 8, interest equals principal times rate times time, etc. Using the chart that we learned from the dirt problems, extending it just a little bit, and coming up with a strategy to solve some apparently very different, but actually very similar types of problems. Okay, so that does it for this whole series of videos.